Okay, this video is going to encompass two groups. It's going to have both the geometry and the Algebra 2 students because I'm doing the same lessons for both of you at this point, simply because these are things easier to learn than doing proofs, especially when you're trying to do it on your own. So the next lesson we're doing is 7.2 is the next set of homework, and it's on theoretical and experimental probability. So we have to understand the difference in them first. So I have the two things written up here. Theoretical probability is just what's possibly going to happen. So the favorable outcomes, or the number of favorable outcomes, or the outcomes we're looking for, divided by the number of outcomes in the sample, or the number of outcomes we're going to use. Okay? And then we'll deal with this complement formula a little bit too, but that might come in a later time. The other one is experimental probability. This is one where we're actually going to do it. We actually got the data from doing it. So it's the number of times a specific event did occur over the number of attempts or the number of tries, or in the book I think it says number of trials. Okay, so there's some important differences between them. Those differences become how we're looking at it. So if you're looking at your PowerPoint and you're on example 1, each letter of the word probable is written on a separate card. The cards are face down and mixed up. What is the probability that a randomly selected card is a constant? Okay, so I don't think it's supposed to say constant. Consonant, if I read right. So there's 8 letters in the word probable. 3 of them are vowels. So that means that the number in the sample is 8. The number of favorable that are consonants is 5. So 5 over 8, or 62.5%. So theoretical is just something that, here's the number of possibilities, here's the number that we want. It's not how many did we actually do. Okay, so after seeing that and understanding that, you can look at example B, which has all the things from a dice there, right? So if all the sides of 2 dice, so you have a red dice and a blue dice, the probability of getting 2 1s, 2 2s, 2, and so on, that's what that whole thing is spread out there saying. So when you add those up, you have 1, 2, 3, 6 across the top, and 6, so it's 6 by 6. So you have 36 possible outcomes, number in the sample. That the difference in them is 4. Well, how many of them give you 4? So 4 out of 36. We have to count those 4 because we have to figure it out. Where's the difference? 5 and 1 and 1 and 5. There's 2. 6 and 2, 2 and 6. There's 4. Those are the 4 that work. So 4 over 36, which is 1 over 9, like your PowerPoint in example B says. Okay? So that's the gist behind theoretical probability. You can look through those other examples and you can see the answers in the back. Okay? So if it's saying what's the probability, or a complement, I should say, the probability of an outcome of event E is the number 1 minus P of E, where P is not what we're looking for. Okay, so that one will come with an example problem a little bit later that we'll look at. So let's go and look at experimental probability then. I think that starts with example 4. Nope, must be example 5. So we go back to this. So now, in experimental probability, we know 5A is where I'm at. We know what the total number of occurrences of a certain thing happening. So we had a spinner that had 4 sides to it. So the possibilities were 1, 2, 3, and 4. Okay? Then we did that thing. We spun it. So when we spun it, we got a 1 6 times, we got a 2 11 times, we got a 3 19 times, we got a 4 14 times. So it's asking, what's the probability of spinning a 4? Well, we have to add up the total number of occurrences. So in that case, the total number of attempts or tries goes on the bottom. So 6 plus 11 plus 19 plus 14, all over, how many times do we get a 4? Or all under 14. So we add this up and we get that 14 out of 50. We reduce 7 over 25, which is 0.28 or 28%. Okay. Now, that is very similar to the way the last problem in your homework works. It's asking us to figure out the probability, and actually I'll even just grab it and read it to you, and I'll get you started on it and see if you can figure it out from there. So calculate the probability of randomly guessing at least 7 correct answers on a 10-question true or false quiz to get a passing grade. How many possible combinations are there? How many attempts or tries are out there that we could figure this out from? There's 2 times 2 times 2, because there's 2 possibilities for each of these, right? How many times? 10 times. So 2 to the 10th power is 1024, I believe. Your job is to figure out the number that goes here. Since there's 2 things, or 2 possible outcomes of each one, what's the likelihood of getting 7 of them? I'm hoping that'll give you some help. I'm hoping that'll help you a little bit with this section. It still shouldn't be overly confusing if you're doing the work of reading the chapter, looking through the PowerPoint, and starting to understand it from your notes. If you're not, it probably is going to be harder for you because you're just trying to do the work without doing the work. Let me know if you need anything else.